Hello everyone. So today's lesson is going to be on significant digits. These are going to become important when we're doing both chemistry problems and later on physics problems. Significant digits are any digit that is used to indicate how precise a measurement needs to be. So they're used to indicate the level of precision or accuracy of a measurement. So I'll give you an example here. If I told you to go to the scale and measure out 6 grams of salt, okay? So if I just said 6 grams, you could get 6.1 grams, you could take 6.3 grams, or even 6.5 grams. We'll go almost halfway to 7 grams, and it would still be acceptable because I asked for 6 grams. I wasn't very specific. I wasn't very precise in the amount of salt that I asked you to get. But if I said I need 6.00 grams of salt, that means that if you went to the scale and you got 6.01 grams or 6.02 grams, that would not be acceptable. What you need to have is you need to have your scale read exactly 6.00. So the first measurement is given to one significant digit and is therefore less precise than our second measurement, which is given to us to 3 significant digits. So then exactly what counts as significant digits? And we can abbreviate significant digits as SDs. It just makes it a lot easier to write, not having to write the word every time. So a significant digit is any digit. It could be a 0 or a non-zero digit that counts towards the precision of a measurement. Okay, so any digit that contributes to the precision of a measurement. So in order for this definition to be complete, then we have to see what contributes and what doesn't contribute to the precision of a measurement. There is something called trailing zeros. And these are the zeros that come after any non-zero digit. So for example, if I gave you 6.350, this particular zero is a trailing zero. Now trailing zeros, they do count as significant digits. So when I look at 6.350, this particular measurement has 4 significant digits, okay? If I gave you a different number that instead of trailing zeros has leading zeros, like for example, 0.00250, these zeros, the leading ones, do not count as part of significant digits because they don't contribute to the precision of the measurement. They're just indicating that I'm dealing with a decimal. And so these guys, they don't count. As significant digits. Whereas the other 3 digits, 2, 5, and the trailing 0, they do count. And so here I have a number that has 3 significant digits. So when you're working on a chemistry problem or when you're working on a physics problem, you might ask yourself, well, how do I know how many significant digits to use? And for this, the answer is in the question. So the question itself will indicate how many significant digits the answer needs to have. And I think, again, in order for us to illustrate that, an example is probably the best way to do it. So let's say I gave you a physics problem. You haven't done physics yet, but we're gonna see something that works with physics. Let's say that I had a bike, travels at, let's say 30 meters per second for 5.2 seconds, okay? What distance does the bike travel? Okay. And so here, when I look at my question, I see that I have 2 significant digits there, 2 significant digits there, and therefore my answer needs to be the 2 significant digits. Now let's say that instead of writing 30 meters per second, let's say that I had said, what if it's going at 30.0 meters per second? Now I have 3 significant digits for this measurement, and I have 2 for that one. If you're given multiple significant digits in your question, the rule is you always go with the lowest number, okay? So let's make sure that we write that down. If you are given multiple significant digits, then you choose or you use the lowest or the least precise measurement. Okay. So let's say that we left the question this way. We have 3 significant digits for one, 2 for the other, and therefore in this case my answer needs 2 significant digits. So I'm gonna need 2 for this particular question. All right, so I'm gonna work the question out. Obviously this is something that you will learn later, but I know from physics that in order for me to calculate the distance, I need my speed times my time. And so the speed is 30.0 meters per second. The time is 5.2 seconds. And so when it's all said and done, what I see is that the answer here is going to be 156 meters, okay? So when I look at my calculator, the answer is 156, which is 3 significant digits. I need my answer to have 2. So how do I go about writing this in 2 significant digits? Well, I can do it 2 ways, okay? So I'm gonna give you 2 different ways. I could take my answer, which is in meters, and I can convert it to kilometers, right? So what I could do is I could divide by 1,000 and give the answer in kilometers. So I could say 0.16 kilometers. Now, why is it 1.6? Well, I'm gonna need these 2 digits, right? I'm gonna need those 2. And so I'm gonna write 0.15, but the 6 over here is going to round up the 5 into a 6. Okay, so I always have to look at the digit that comes after. If it's 5 or higher, it's going to round up. And if it's lower than 5, then it's gonna keep the digit the way it is. It's gonna stay whatever it is. Okay, so if this was 154, not 156, then that would be at 0.15. All right, so I could do that and give the answer in kilometers. Or here, for my second options, what I could do is I could give my answer in scientific notation. Scientific notation, what it does is it gives the answer as a power of 10, a number that is being multiplied by 10 so many times in order for you to get the actual number. So in scientific notation here, if I have 156, that's the number that I'm dealing with right now. And this is where my decimal is right now. It has infinite zeros afterwards, and therefore I don't have to write those down, but that's where my decimal is. I want this number to be 2 significant digits. So what I can do is I can take my decimal and I can move it to after the very first integer, after the very first number or digit, and I can say, okay, so then I would have wait a second, it's not a 5, because don't forget that this is going to round that up into a 6. So I could have 1.6, and then I would write it down times 10. Now, how many times did I have to move my decimal? 1, 2 times. So this is going to be to the power of 2 meters. 1.6 times 10 to the 2 meters. Okay. I'm going to give you another example with scientific notation just to make sure that we kind of have an idea on how to do that. Let's say that I had example 2. 653,314. Okay, and I want this number written in 2 significant digits. Okay, so again, I needed 2 significant digits. So this is where my decimal is right now. And I'm going to need to move my decimal 1, 2, 3, 4, 5 times. So you always want to move it right after the very first digit. And so I'm going to write 6 point. That's where my decimal is right now. Let's look at this number. Comes next. It's a 5. Is it going to get rounded up? Nope, because this number is a 3, so it's not. So it's just going to be 6.5 and then times 10. And again, we said we moved it 5 times. So it's going to be 6.5 times 10 to the 5. Okay, so when you're going to the left, you're always going to have a positive number. If I wanted to use scientific notation to write a number that was a decimal, so for example, 3, the answer I get in my calculator for a particular problem is 0.00035192. Okay, so it's like that. And what I want is I want this to be written in 3 significant digits. Okay, so you can do it 2 ways here. If I wanted to write it just in significant digits, remember that 1, 2, 3, and 4 don't count as sig digs. So really all I need is the next 3, 5, and wait a second, that 9 is gonna round this up to a 2. So I could write it like this. Or if particularly the question says I want it in scientific notation, then I would write 3.52 because I need 3 sig digs. And let's see how many times I had to move this decimal. 1, 2, 3, 4 times. But this time I moved it to the right. So now it's going to be times 10 to the negative 4. Okay, so this concludes the section on significant digits and a little bit about scientific notation. You might need these when we do some chemistry problems or some physics problems, and we'll see you guys again next time.